And welcome back, everyone. Let's pick up where we left off. We're going to start with ratio scale. So, what is ratio scale all about? A scale can be written as a ratio. The ratio represents the relationship between the distance on the map and that same distance in reality. All right, so that's how we're going to talk about this now. Remember, ratio deals with the same unit. So a scale has no units. And when we look at this now, let's get the next one out. The scale of the map will then be written in the form map distance on the left to actual distance or distance in reality, how you talk about it, on the right-hand side. And the two dots, the semicolon, those two, that separates the two. All right, let's see how this works in an example. So the scale of a map is 1:5,000. If the measurement on the map, all right, so we know where we're working, is 3 centimeters, calculate the distance in kilometers in reality. All right. So we'll start with the scale. There it is. Now notice what I've done. I've separated again with those two dots, the semicolon. On the left-hand side is map, on the right-hand side is reality. And how do we read this? 1 unit on the map is 5,000 units in reality, because we have no real unit of measurement there. So, if the measurement on the map now is 3 centimeters, that's on the left-hand side of that system. There it is. Let's circle it for you. So that 3 represents the distance on the map that we measured. How much is that really in reality? Here's how we do that calculation. We start with division. And why is it division? Because these two numbers above each other, we would divide. And the numbers across from each other like that, there we go, we would times. All right, so those are the two operations we're doing. Divide by the number above, times by the number across. Here's how we'll write that down. 3 divided by 1 times 5,000. You can swap that around. 3 times 5,000 divided by 1. We'll still get the same answer. You're doing good work. So, that gives me 15,000 centimeters. Remember from the question, all the way up here, we needed the answer in kilometers. All right, let's just ring that better. We need the answer in kilometers. So, we've got to do some conversions. As a result of that, I've brought up that leapfrog system. Let's try that one. So I'm traveling from centimeters here to kilometers all the way on that side. So I've got to follow the arrows. And the arrows tell me I've got to jump from centimeters to meters, and I've got to divide by 100. It's the first one. Then I'm not yet done, because now I'm at meters. I've got to go from meters to kilometers and divide that by a further 1,000. That's how we'll convert. Remember, you could have used this leapfrog system, or you could have memorized them, all of the different conversions. Up to you. So in this case, I've done that. There it is. Divide by 100 first, divide by 1,000 thereafter, and my answer, 0.15 kilometers. Nice work. Let's try another example. So if I look at the next one, the scale of a map is now 1:1,000. If the measurement in reality this time is 5 kilometers, calculate the distance in centimeters on the map. So in this question, we're now trying to find the map's distance. Procedure is kind of the same. Let's see what we got to do. We first line things up with the map on the left-hand side and reality on the right-hand side. There's my scale. Then we are given 5 kilometers. There it is, that 5. All right, so it went on to the reality side. Remember, that was given to us in reality. It says it there. Then, numbers across from each other we would times, and numbers above each other we divide. There we go. Let's write that in maths now. So 5 divided by 1,000 times by 1 Again, we could have written it the other way. 5 times 1 divided by 1,000. Same answer. Nice work. Almost there. So we get 0,005 kilometers. All right. Again, in this situation, we've got to convert. We've got to convert from kilometers to centimeters. There we go. This time our answer has to be in centimeters. Remember the two ways in which we can convert? We can use the frog, like with the previous example, or we could have memorized the conversions. So in this case, I'm going from kilometers to centimeters. So that's kilometers first. Then I've got to jump to meters. Then I'm going to jump to centimeters. So that's a 2 there. And in this case, we will times. So I'm timesing by 1,000. And I'm timesing by 100. Nice work. Gives me 500 centimeters. Let's just put that up there. There we go. Great stuff. All right, let's see what else we've got to do. So, I now talk to you guys about bar scale. That sounds fancy. We need to measure the distance with a ruler this time to determine the relationship between the map distance and the actual distance. So remember the map and actual, that's where our scale comes from. Yes. So looking at this particular blocks, we will use a ruler to measure distances there and then develop a scale with that. Let's look at an example so I can show you guys how to do that. The distance between two towns is 1.4 centimeters. Let's just ring that as centimeters. Using the given bar scale, so we don't have it yet, there it is, determine the actual distance between the towns. So if you look at this bar scale, it's different to the previous one. The method is identical, regardless of the type of bar scale you are given, or you see when you're working these things out. The process is identical. Where we start is we measure the distance between this point and that point. That's where I've got to start. I've got to measure this distance. And when I measure that distance, I got 7 centimeters. That's where the 7 comes from. That 7 is the distance between the 0 and the 50 that you are looking at. All right, so what am I saying? I'm saying that 7 centimeters that I've measured is equivalent to the 50 kilometers there. That's how we're looking at this. Now remember, ratio has no units. Scale doesn't have any units. So what I've got to realize here is I need to make both of these the same. It's currently in centimeters and kilometers. So what have I done here? Centimeters I've kept. I've changed that one also to centimeters. So from kilometers to centimeters, what did I do? I divided by 1,000. Oh, wrong one. I times. What am I saying? I times this by 1,000. That's much better. And then I times it by 100. And that's how I got 5 million centimeters. It sounds like a lot. Let's see what we're dealing with. Remember, this has to do with actual distances. So in kilometers. And that's why it sounds like such a big number. So here's the mistake. All right, please take note of this. Not converting to the same unit, like we've just done there, where you leave it as 7 centimeters to 50 kilometers. We can't work with them. They're not the same. That's the problem. So you have to be aware of that. So here we go. Where does the 1.4 come from? Let's just remind you about that. There's the 1.4 centimeters at the top. That's the distance between the two towns on the map. All right, so like I did before, we line it up there. On the left-hand side was the map. On the right-hand side is reality. That's what we're doing. So what have I got to do? Just want to take this out of there because we've seen that now. I say numbers above each other we divide, and numbers across from each other we multiply. That's why we're dividing there, and we are multiplying there. So we get 1 million centimeters. Now remember, they say determine the distance between the towns. Oh, there we go. Determine the actual distance between the towns. The actual distance will be in kilometers, so convert centimeters back to kilometers. I've got to divide by 100. I've got to divide by 1,000. And then I get, at the end, 10 kilometers. Great stuff. Let's do the next example. So the distance between two towns is 2,5 centimeters. Using the given power scale, there it is, determine the actual distance between the towns. So again, we've got to measure from that point to that point, right at the end. That'll tell us the distance in centimeters. So like the previous example, I got 7 centimeters. 7 centimeters is to 50 kilometers. And if you remember, like the previous example, we've got to convert the kilometers to centimeters by multiplying by 1,000 and then multiplying by 100. So, therefore, 7 centimeters is equivalent to 5 million. One more zero, yes, centimeters. There we go. All right, now we can bring in the 2.5. So if the distance between the two towns is 2.5 centimeters on the map, remember, if we use those two dots, the left-hand side, map, the right-hand side, reality. So looking at the semicolon again, the left-hand side is the map distance we get, which is 2.5. All right, and we've got to work out that side. Nice work. Let's think about it. In that situation, what do we need to do? Numbers above each other, we divide. Yes. Numbers across from each other, we multiply. Well done. Therefore, 2,5, always start with that bottom number, divided by 7, multiplied by 5 million. Nice work. All right. Ooh, that didn't come out quite nice. That's much better. That gives me 1,785,714 centimeters, which I don't want. I need this answer to be in kilometers, so we're almost there. We've got to divide by 100 to get it to meters, divide by 1,000 to get those meters to kilometers, and we end up with 17,86 kilometers. Very well done. Let's take a short break, and when we get back, we'll carry on. See you soon.